Every year, the ocean absorbs 25% of human CO2 emissions, which is a really huge service the ocean provides us, in that it's keeping that extra CO2 out of the atmosphere. If the ocean wasn't taking up that extra CO2, we would have already overshot a key threshold, and that's 1.5 degrees Celsius of atmospheric warming. Before humans started putting extra CO2 in the atmosphere and the ocean were at equilibrium in terms of the amount of CO2. So what we're observing today is the ocean seeking to maintain that equilibrium. But it does come at a cost because the ocean's chemistry is changing as a result of that, something that we call ocean acidification. Oceanographers have been measuring surface CO2 in the ocean for over half a century. And we do this by installing CO2 instruments on what we call ships of opportunity. So that could be research vessels that are traveling the globe on various science missions, also on cargo vessels that are primarily in the Northern Hemisphere. And so the big challenge that we have today is filling our observing gaps in the Southern Hemisphere. The Southern Ocean connects all of the other ocean basins, and it's an important driver for our climate. But it is very remote. It has often really harsh conditions that you don't want to send people into on a ship. And that has really prevented us from taking enough wintertime measurements for us to really understand the Southern Ocean's role in climate.
Making advances in ocean technology and autonomous platforms can help us address observing gaps in the ocean. I work on developing and testing ocean carbon sensors and using their applications to study CO2 uptake and ocean acidification. So a big part of our focus in the last decade was to come up with more autonomous observing solutions to make ocean carbon measurements.
And in 2019, we were actually able to send the first ocean robot completely around Antarctica, collecting wintertime measurements all throughout the Southern Ocean. And now we're able to send these uncrewed surface vehicles into big storms, even into hurricanes, where we haven't been able to make measurements before. And so we're learning a lot about air-sea CO2 exchange in these big storms. Filling these observing gaps and feeding the new data and knowledge into our regular assessments of global climate is becoming increasingly important, particularly as society moves toward reducing CO2 emissions and testing approaches for enhancing the ocean uptake of CO2, with approaches like restoring coastal habitats that sequester carbon and using other technologies to extract even more CO2. And we need to track ocean CO2 uptake better to inform society about whether those CO2 reduction approaches are working. Ocean carbon uptake impacts everyone on the planet. It impacts our climate. It impacts our weather. It predicts what a future ocean and world will look like. There's so much more for us to learn about this critical issue. And that's why myself and other scientists at NOAA's Pacific Marine Environmental Lab are dedicating so much of our time to studying this issue to help maintain a healthy planet and healthy people.